All right, today we're going to go on a pretty incredible adventure. We're going to follow this one tiny little water molecule as it journeys through all these different worlds, changing its form and helping us get a real grip on the fundamental states of matter. So, you ready? Let's dive in.
So it all starts with something you've probably seen a million times. You see a puddle after it rains, and then a few hours later, poof, it's just gone. Where in the world did it go? Well, the answer to that question is exactly where our little molecule's amazing journey begins. To really understand this journey, first we've got to explore the three main worlds or states that our water molecule can exist in. And these are the fundamental states of pretty much all matter: solid, liquid, and gas. Okay, this chart really breaks it down for us. When you're looking at a solid, think of the particles as being totally locked in a tight formation. Then you've got liquids, right? They're still close, but now they've got a little wiggle room to slide past each other. And in a gas, whoa, they are completely free, just zipping all over the place with tons of space between them. It's this difference, how the particles are arranged, that gives each state its own special properties, like its shape and how much space it takes up. So let's picture our molecule as part of an ice cube. It's kind of like being at a party that's so crowded, you're just shoulder to shoulder with everybody. You can't really move around, you can only kind of vibrate in place. And that's exactly why solids, like ice, have a fixed shape and a fixed volume. All those molecules are locked into this really rigid structure. Now, what happens when we add a little heat? Well, in the liquid world, our molecule can finally start to move. The party has thinned out just enough to let everyone slide and weave past each other. This freedom is why liquids can flow and take the shape of whatever container they're in. But the molecules are still pretty close, so the volume stays the same. And finally, the gas world. With even more energy, our molecule breaks free entirely. Now the party is wide open. Molecules are zipping around like crazy, bouncing off each other and the walls. They're so far apart and have so much energy that they'll expand to fill any space you give them, which means they have no fixed shape or volume at all. So how does our molecule make that huge leap from the liquid world to the gas world? Well, the secret ingredient is energy, specifically heat. Heat is the key that unlocks the door from one state to the next. Let's see how it actually works. This great escape has a name: evaporation. It's the process where a liquid, just like the water in our puddle, turns into an invisible gas we call water vapor. The main thing to remember here is that this whole transformation is fueled by heat from its surroundings. And there it is, the main power source in action. The sun's energy gives those water molecules right at the surface just enough of a kick to break free from their buddies and escape into the air as a gas. That is exactly what happened to our rain puddle. But hold on, there's a little twist in our story. Evaporation isn't the only way for a liquid to become a gas. There's also boiling. And even though they both get the same job done, they are two totally different kinds of escapes for our little water molecule. This slide really lays out the key differences. Evaporation is a slow, sneaky process, right? It only happens at the surface, and it can happen at pretty much any temperature. Boiling, though, that's a whole different ballgame. It's a fast and furious process that happens at one specific temperature, 100 degrees Celsius for water, and it happens throughout the entire liquid. That's where all those bubbles come from. So here's a fantastic way to picture it. Evaporation is like a few molecules sneaking out the side door, one by one. Boiling is when the main doors fly open and everybody just rushes out at once in this huge, energetic, chaotic party. Okay, so our molecule is now a free-flying gas particle. But you know what they say? What goes up must come down. So what happens when it loses all that energy and decides to rejoin the liquid world? Let's follow its journey back. This return trip is called condensation. It's the exact opposite of evaporation. When that warm water vapor in the air bumps into a cooler surface, it loses heat, slows way down, and turns back into tiny little droplets of liquid water. It's pretty amazing. And guess what? Condensation is happening all around us, all the time. You know those little drops of water on the grass in the morning? That's dew. That low-lying cloud you might walk through on a hike? That's fog or mist. Even those beautiful, icy patterns on a window in winter, that's frost, and it's also a form of condensation. And hey, here's a fun fact for you. What's the real difference between fog and mist? It's actually all about visibility. If you can't see more than a kilometer ahead of you, you are officially in fog. If you can see further than that, it's just mist. Pretty simple, right? So we know our water molecule can escape through evaporation, but can we change how fast it happens? You bet we can. The environment around it plays a massive role in how quickly our molecule can make its big getaway. This table breaks down the three main things that speed it up. First, you've got wind speed. A good breeze sweeps away the water vapor, clearing the air for more molecules to escape. Second is exposed surface area. A wide, shallow puddle is going to evaporate way faster than the same amount of water in a deep cup. And third, temperature. The warmer it is, the more energy the molecules have, and the faster they can break free.
So if you want an easy way to remember these factors, just think of the mnemonic WER. W for wind, E for exposed surface area, and R for the rate of temperature. It's a simple little trick to recall the three keys to speeding up evaporation.
So we've followed our single molecule as it changes from liquid to gas and then back again. But, this isn't just a one-time trip. This journey is part of a constant, never-ending story that literally shapes our entire planet. And this slide really captures the whole thing. Our water molecule is constantly moving between being a solid, a liquid, and a gas. It evaporates from the ocean, condenses into clouds, falls as rain, maybe even freezes into ice, all before starting that journey all over again. This is the water cycle, and it's endlessly powered by the simple heating and cooling of our planet. And this whole journey brings us to a really cool final thought. I mean, we've seen that even something as simple as a puddle, which looks totally still, is actually buzzing with invisible activity. So it kind of makes you wonder, right? If water is always in motion, what else is out there that looks completely still but is actually part of some huge, dynamic, never-ending cycle? Something to chew on. Anyway, thanks so much for joining us on this adventure.